Let's go through some select homework problems from 4.4b. This is on topics on average value formula and second theorem, fundamental theorem of calculus. All right, so here's the average value theorem. F of c is equal to 1 over b minus a times the definite integral from a to b of f of x dx. So essentially, this is saying height is equal to the area divided by width. Okay, so we start off with our function. We have lower and upper bound. So we're trying to find the average height, average value, plug into our formula. This represents 1 over width times the area is equal to the height. So we simplify x minus 2x to the 1/2, go through power rule, simplify, evaluate between your upper and lower bounds. So plug your upper bound in first, f of b. This represents f of b, f of b minus f of a. So I left f of a out because I plug 0 in, I'm just going to be left with 0. So that comes out to be 2 minus 4/3 square root of 8. So times 1/2. Okay, so here's our area, here's our width. Multiply that together, we get average height is 1 minus 2/3 square root of 8. Okay, so now the next step is find the location, the x value, where the graph is going to hit this average height, where it's going to reach this average height. So we can set the original function, c minus, or x minus 2 root x. So if I'm using c, since we're solving for c, so c minus the original function is equal to the average height that we're looking for, 1 minus 2 root 8 over 3. And then we just go through and try to solve. So c minus 2 root c minus 1 plus 2 root 8 over 3. So this is not factorable, but what we can do is if we bring everything over to one side, plug in the calculator, then we can simply look for the x-intercepts. Okay, so if you plug in your calculator, and if you zoom in, you're going to see that the graph is going to cross the x-axis twice, once at 0.438 and then once at 1.79. So we have the c values where the average height will reach this 1 minus 2/3 root 8. Okay, 45. Find the average value and then find the c value. So we just go through our theorem. So 1 over b minus a from times the definite integral from a to b of our function. So 1 over b minus a, this reduces to be 1 over pi over 2, and then we evaluate between our lower and upper bound. F of c is equal to 2 over pi times 2 tangent x. Evaluate between upper and lower bound, plug pi over 4 in for x, minus, then evaluate f of a, and all this comes out to be 4. So 2 over pi still represents the width times the area, and we're going to get 8 over pi. So average height, average value is 8 over pi. So we set f of c equal to 8 over pi. Our function that we're dealing with is 2 secant squared x, or 2 secant squared c, and simplify, solve for x. Secant squared x is 4 over pi, so I can make cosine squared x equals pi over 4. Cosine x equals plus or minus root pi, square root of pi over 4. And so when we bring the cosine over to inverse cosine, this plus or minus is for the inverse function. Okay, so we pull the plus or minus out. It's not going to go with the square root of pi over 4. So inverse of square root of pi over 4 is 0.4817, so we simply get plus or minus 0.4817. Okay, 47. We have our function, we have our bounds, 1 over b minus a, definite integral from a to b of f of x. Okay, we just go through the steps here, evaluate between your upper and lower bounds, and all this will give us our height, our area divided by the width will give us our height. Average height is 8/3, f of c is equal to 8/3. Set our original function equal to 8/3. We want to find out when the average height is reached. So here we can just isolate c squared, take the square root of both sides, plus or minus square root of 4 over 3. And we have two values. We do want to make sure that our c values fall between our intervals. Plus or minus 1.155 does fall within our interval there. Okay, let's look at 49. Okay, again, we have our function. We want to find the average value and then find the c value, plug into our formula, 1 over b minus a, definite integral from a to b of sine of x, and 1 over pi, that represents the width, definite integral of sine x, so sine x becomes negative cosine x, evaluate between 0 and pi. All of this comes out to be 2 over pi, or actually 2, so area is 2 divided by the width, pi, so we get 2 over pi. Okay. Now 2 over pi, we want to find out when sine is equal to 2 over pi. We're only looking at the first and second quadrants, right? Because because our bounds are from 0 to pi. Okay. So then, plug in the calculator, we're going to get 0.69 is our c value, and the other c value is going to be pi minus 0.69. Okay. So we have two values here, 0.69 and 2.451. Okay, number 60, find the average value of our function over the interval from 0 to 6. Okay, so here we have an area that is 1.5. We have this area, which is b. Well, we know the definite integral from 0 to 6 is going to be 3.5. Right, so we want to find f of c. So f c is simply 1 over b minus a, definite integral from a to b of f of x dx. So we just plug this information in, 1/6. We know the definite integral from 0 to 6 is going to be 3.5, so the average height is simply going to be 3.5 over 6 over 7/12. Okay, 75. These are mostly using the second theorem of calculus. So all we do is we look to see if our conditions are met. We do have our lower and upper bound, with the upper bound being the variable. So to find the derivative of this function, we simply follow the rule here. So plug the upper bound into the function as you see it, x squared over 2 plus 2x. For 75, we're actually going through the process of finding the integral first and then finding the derivative. So we're not using second theorem of calculus just yet. So find the integral, we get x squared over 2 plus 2x, then find the derivative, and that's going to come out to be x plus 2. Now, if we did use second theorem of calculus, we will get x plus 2 as well. Okay. 83. Right, so this is a problem where we can, 83, we can use second theorem of calculus. We simply can find, apply the rule. But for 83, we're still finding the step-by-step. So we can write this as x to the 4th plus 1 to the 1/2 times 1 is equal to square root of x to the 4th plus 1. And we're going to simply set it up, 83 being the definite integral from -1 to x of t to the 4th plus 1 to the 1/2 dt. Okay, 87, now we can see if we can apply second theorem of calculus. It's actually not going to work because we have both bounds being variables. Okay, neither bound is a constant. Neither bound is technically not going to be 0. Okay, it's a constant. Okay, so we got to take this step at a time. We got to find the definite integral for 4t plus 1, and then we can evaluate using the derivative. Okay. So plug the upper bound, after we find the integral, plug the upper bound in, and then plug the lower bound in. So we're going to be left with 2x squared plus 8x plus 8, and everything cancels out to be just 8x plus 10. Okay, the last few here, 89 and 91. Okay, if we want to find the derivative of this, we can use second theorem of calculus. So first thing we do, we plug the upper bound in. So we simply get sine of x to the 1/2 times the derivative of sine x, which is cosine x. Okay, 91 we can also apply using second theorem of calculus. So plug upper bound in for t, so we get sine of x cubed, quantity squared, times the upper bound's derivative, so x cubed becomes 3x squared. And we'll simplify this to be 3x squared times sine x to the 6th.